Hello, everyone. Welcome to the lab session of Quantitative Trading Strategies. In this lab session, we're going to talk about the momentum trading strategy. So let's get started. So first, we install the YFNS package in the Colab environment, and then import the necessary packages. So let's just recap what the momentum trading strategy is about. So the momentum trading strategy is basically a strategy that looks at going a long position for the top performers and going into a short position for the bottom performers, right? So for a group of assets, and the underlying assumption is that the top performers will continue to outperform the rest, and then the bottom performers will continue to underperform the rest, right? So that's the idea of the momentum trading strategy. So first, let's look at how to retrieve the set of assets in terms of the stock symbols. So here we use the Beautiful Soup package to script some information from the web. So here I've put here the URL for Wikipedia, in terms of the Dow Jones Industrial Average introduction page. So in the page itself, there's a table that describes what are the constituents for the 30 stocks in DJI. Now, so this is a routine to get the data in terms of the constituents. Specifically, we use the requests to send the request HTTP request to the web, and then get information from the URL, and then use the Beautiful Soup to grab the information in terms of the content, and then find all the information that matches a table format, right? So this is to using the Beautiful Soup's functionality to locate the table. And in the web page, there's only one table. The table is here. And then we use pandas function read HTML to read the data from a HTML format to a data frame. And then we do some processing, return the table. So look at the results. By calling the function, we see that we have this table here. And this is a table we need to serve as the group of assets to be looked at at each time frame. So here specifically, we're going to use the symbol column, right? So here we access the symbol column and then just get the values and then copy to the list. Right? So here are the 30 constituents. So note that these 30 constituents may not necessarily stay the same. So different times they may change. All right, so with these tickers, we can treat them as a list and then pass in the download function from YFNS. In this case, we're looking at the January to September 2021 in terms of time frame, download the stock data, and then here's the data we have. Because there's a lot of information here, we're just going to focus on the adjusted close, right? So here we have a nice data frame with the dates of the index, and then each column represents the adjusted closing price for that specific stock and for each day, right? So let's continue. We're going to look at a monthly level, so instead of daily level, because month is more of an aggregate measure in terms of the performance. So we're going to use the resample function to do the conversion for us, to do the aggregation. Specifically, remember that the percentage change function returns us the percentage returns for each stock on a daily basis, because the raw data is for on a daily basis. And resample basically means we are looking at for each month, right? All the daily returns. Let's just aggregate together. So this is to say for each month, aggregates all the daily returns, and then the AGG function gives the specific aggregation method. So here, the aggregation goes by this way. So we're going to convert it to 1 plus R format, right? So this is in percentage terms, 1 plus R. Do the product, which is to multiply all the daily cumulative returns, right? So this gives us the terminal return in 1 plus R format. And then -1 means to convert it back to the simple returns. So this gives us the monthly returns data frame, which looks like this. So here we have the dates, which is the end of each month. So it's January, February, March, right? So here we have the monthly level data in terms of the simple returns for each stock, right? So here I've provided a simple example to understand better the resample function here. So we're going to create a simple list, right? From 0 to 8 with the indices here. So this is index. It's a Python series with the time index. And now what the resample function does is basically to say, I want to resample by 3 time steps as a group, and then sum together to produce one aggregate measure, right? So we can go, the first 3 add together is 2, it's 3, right? So that's why I have 3. And then 3, 4, 5 is the second group because this goes by 3 time steps. So which adds up to 12, right? So that's gives us the aggregate measure. All right, so let's continue to the calculation of the previous terminal returns for moving window, right? So we want to use a moving window because just purely look at 1 month return is a bit short, right? Want to assess based on the historical average, right? So what is the cumulative terminal return for the past 6 months, right? So we calculate the terminal 6 months return similarly. So first we convert the simple returns to the 1 plus R formats, right? And then look at the past 6 months return. So talk about the rolling method. Rolling basically means let's roll back by 6 periods or 6 months, including the current month, right? So with all the 6 months data, we multiply them together. So this is apply method basically means to tell us to pass in the function, and this function is to multiply them together, which gives us basically the cumulative return in the 1 plus R format. And then minus the 1 gives us the simple returns. So this is past cumulative returns data frame, which looks like this. Right. So first 5 months, we do not have any data because there's no previous data to apply the NP dots products method, right? And then so the data starts from the 6 months. All right. So now now comes to the training signals. So we're going to formulate the training signals by first dividing or defining the different periods. So we have 3 periods. The first period is the end of measurement period, right? So this gives us the historical data which we use to make trading decisions, right? So this is all the historical data until the 30th June 2022, right? And then this formation period means that this is current month we are living in, right? We are living in July. So we look at the data historically, which is all the data until June. And then we're going to make a decision in the July. And then in August, this is where we do the assessment to see how good is the trading strategy. So that's the different 3 periods we have. Now, here we're just doing the selection of the corresponding data set. So here we're just selecting the data that's belonging to the end of measurement period, which is June. But this data set itself is a reflection of the historical 6 months terminal returns, right? Cumulative returns. So data looks like this. We have different stock symbols. We have the cumulative 6 months returns here, right, in the simple returns format. So this serves as the space for selection, right? We're going to select stocks based on the returns here. Specifically, you want to look at who are the outperformers, who are the underperformers, right? Just give an example. Here we are extracting the stock with the highest return the return again being the 6 months terminal return. So we do this by first extracting the Python series, right? Use the IDX max method to get the index of the maximum value, and then use the log function to access the value. So similarly, we can access the negative direction in terms of minimum. So we have the minimum here. So this again should fall into our group of the outperformance, and then this should fall into the group of underperformance, which we are going to go short, right? The grouping is done by using the Q-cut method. So here, again, this is a series we have, and Q-cut basically performs grouping, right? So here in this case, I'm dividing into 5 groups. So because I have 10 elements, so equally divide. So first 2 elements go to group 0 and then group 1, etc. Right? And now we're going to use the cut function and apply it on the first column. So what's the first column? Basically, it's the returns column here. So this is the returns. So we're going to first order, right? Rank the stocks based on the returns, and then group that into 5 groups. So here's the 5 groups, and this is the results. So we created a new column which could rank, and then each stock belongs to a specific group. So the problem becomes we're going to long the top performers in group, the highest performing group, and then shows the stocks in the lowest performing group. All right, so that's exactly what we're going to do. We're going to use the log function to say which group falls into rank 4, right? And then get the index. Index is basically our stock symbols, and then gets the values. So this is the stocks. This is the group of stocks we're going to go long, right? Because they are top performers. Similarly, for those who are belonging to rank 0, which is the lowest performing group, then we're going to go short, right? So this is the long positions, these are short positions. Then we can calculate the performance based on this strategy. Again, the calculation is at the assessment period, right? So the assessment period comes by giving the proper index. So index is it works like this. So we have the formation period, which is July. Then we're going to move forward by 1 month. So this is our assessment period, right? So in this period, we're going to look at the returns or the columns that fall into the long positions, long stocks. So here, these are the returns, right? So returns in August, who were in the long position, right? Which stocks were in a long position. So this is the performance of the long positions, and similarly, we can go to the short positions, and then this is the returns for the short positions. And so to sum them together, we get the average return for the long positions and average return for the short positions. Because they are short, we give a minus sign, and then we have the final our momentum for profit, or the returns for using the momentum trading strategy, right? Which is 1.5%. And now we compare it with the buy and hold baseline strategy. So buy and hold basically means we're going to go long for all the 30 DJI constituents, right? So this symbol basically means to download all the stock data that's belonging to the DJI space, and then the same period. And then similarly, because they are daily data, we first use the percentage method to calculate the percentage returns on a daily basis, roll it up to the monthly level, right? And then the roll up works by calculating the cumulative returns in the simple returns format. And then this is our results. And then we're going to get the returns for the assessment period. So this again is our assessment period index, right? So we see that it's -4%. Right? So And we know that's because of COVID, and because of high rising interest rates. So the majority of stocks are not doing very well. So they're generally going in a downward trend. But the momentum trading strategy is able to give us a positive return, which is good. Right, so that's it for the introduction and the lab session of the momentum trading strategy. And thanks for watching.